Hello, in this session I will give a demo of how to configure PCCs and PCEs in an IxNetwork client from scratch in a back-to-back topology, followed by PCEP session establishment and PCC traffic generation. So let's start with configuring a PCC. I have two ports. Let's configure PCC on one of them. So by default, a DG is configured with 10 PCCs. Let me configure the IP addresses of these PCCs. Since I'll be giving this demo in a back-to-back topology, let's put all the PCCs in a single subnet and all of them will be talking to a single PCE. Now, apart from IP address, put the gateway IP and then directly move to the PCC stack. In PCC, first of all, the PCEP4 address has to be configured, which is the same for all the 10 PCCs. Apart from this, there are other configuration parameters like max LSPs per PC report. This is used for bundling multiple LSPs inside a PC report message. By default, bundling is off because the number of LSPs per PC report is configured 1. If user wants to have bundling, this number has to be more than 1. Then keep alive and dead interval timer can be configured. Then there is a parameter named return instantiation error. The purpose of this field is if user wants PCC to send PC error message upon receiving any PC initiate message from the PCE, this checkbox needs to be enabled, used for more of a negative testing. And then we have this parameter named expected initiate LSP for traffic. These are the expected initiated LSPs that PCC expects to be learned from the PCE. So these LSPs will be configured on the PCE side and PCE will be installing those LSPs in the PCC. Let us configure per PCC 10 LSPs expected 10 expected LSPs. Let's go to the expected initiated LSP for traffic endpoint. Here let us configure the symbolic path name from IXA LSP1 to IXA LSP50. I will come to this tab again when I will be showing the traffic and discuss about the significance of this tab. Let me go back to PCC and check what is there in the capabilities tab. Since our PCC we are supporting only stateful PCE and PCCs, so these tabs are all grayed out and enabled. User cannot configure them as stateless. This SRPC capability is something that user can disable or enable, and there is this maximize ID depth that gets advertised by PCC inside this SRPC PC capability TLV. Now let's configure a PCE. So PCE stack by default comes up with a single PCE with 10 PCEP sessions with 10 different PCCs. Configure the IPs first. Then let's go to the PCE stack. In this stack currently we have not anything that the user can configure. All these parameters are for future support. We are not supporting these parameters right now in this current release and will be supported in subsequent releases. Now let's go to the PCC group stack over PCE. The PCC group stack over PCE actually defines the PCEP session parameters for each PCCs. As the name suggests, PCC group allows user to group multiple PCEP sessions with PCCs that have common properties like number of LSPs per PCC or number of EROs metrics with which the LSPs are constructed. User should group similar PCEP sessions with different PCCs in a single PCC group. We'll discuss further when we configure them. So in a PCC group, under PCC group, there is a basic and capabilities tab. Under basic, first of all, the PCC IP4 addresses has to be configured. Before that, let me configure another PCC group and distribute these 10 sessions between these PCC groups as 5 in PCC group 1 and another 5 in PCC group 2. Now let's come to PCC group 1. Let's first configure the IP addresses of the PCCs. It was starting from 11.1.1.2, and then this is for maximum LSPs per PC initiate. Again, this is for bundling multiple LSPs inside a single PC initiate message. By default, the bundling is off because the number of LSPs is configured 1. User has to configure more than 1 if he needs bundling. Then keep alive and dead timer interval can be configured, and then the number of LSPs that a PCE will be sending PC initiate message to the each PCCs, that we have to configure here. All the PCC sessions that are there inside this group will be having same number of 10 LSPs per PCC. So this is a global parameter. We cannot configure different number of LSPs on different PCEP sessions within a group. So when these 10 LSPs are configured here, corresponding there will be 10 5 into 10, total 50 rows in the initiate LSP parameters tab. Let's just go back to PCC group and check the capabilities tab. It's same as the PCC capability. PCE we are supporting only stateful, so all these stateful capability, LSP update and LSP installation capability are enabled and grayed out. User do not have control to disable them. SRPC capability, however, can be enabled or disabled. Now let's come to this initial LSP parameters. Initial LSP parameters tab actually is the static TD for the PCE, where the someone will be configuring the LSPs that this PCE will be sending as PC initiated LSP message to corresponding PCCs. So I have configured 10 PCCs, 10 LSPs per PCC. The basic tab, the all LSPs will by default be activated, and these 4 objects, endpoint, SRP, LSP and ERO, these are the must objects in a PC initiate. By default they will be enabled, and these other objects are also can be present in PC initiate message to define a LSP, and they are optional, so by default they are not included. So user, the minimum thing that user has to configure is first of all the endpoint of those LSPs. So let's configure them. Someone can configure the as endpoints as IPv6 addresses as well. Then let's go to the SRP. By default there is no need to change anything in default scenario. The state machine will be incrementing the SRP ID number for each LSP automatically. Similarly in LSP, the LSP IDs will be automatically learned from the PCCs. The symbolic path name, however, can be configured by the user as per his need. Let us configure LSPs from 1 to 50. So there will be 50 LSPs. And the next thing that the user has to configure is the number of EROs these LSPs will be consisting of. Again, this number is a global across the PCC group. All LSPs of this PCC group will be having, let's say, 3 ERO sub-objects. So once I configure 3 here, there will be 3 ERO tabs opened up, and inside the content of all the tabs are same, and we have to configure the sub ERO objects over in these tabs. So here the ERO sub objects can be having SID type of different SID MPLS level 20-bit, MPLS level 32-bit. These 3 types of SID types can be configured along with 5 types of NAI, node ID 6, node ID adjacency 6 adjacency, and unnumbered adjacency. There is all these fields are available for the customer or the user to use. Let's configure these arrows as MPLS level 20-bit and configure some labels over here. If NAI needs to be used, then user can choose the NAI. If bit has to be disabled because a bit set means NAI type will be null, and then user can configure corresponding IP addresses over here. Now since we are configuring MPLS level 20-bit, let this be not applicable. Let's go to ERO2 and configure the levels. Similarly, metric also we can have more than one metric, and you have to include the metric if user wants to advertise those metrics as part of LSP PC initiate LSP message. The metric type, there are 4 types of metric type available. User can configure whatever he wants. Let me not use these metrics in the PC initial LSP. User also can configure bandwidth and LSP attributes for the LSPs. Now let's go to the second PCC group. First of all, the IP address has to be configured. Similar parameters here as well. Let's configure these LSPs per PCC is 10 also here, and capabilities is the same. Let's not change anything. Then go to the initial LSP parameter where the LSPs are statically configured. Let's configure the IP4 addresses, or we can have IPv6 version over here. Don't change anything on SRP. LSP, let us configure the LSP names from 51 to 100. So I have used all LSP names as unique. XLSP1 to XLSP50 in PCC group 1, and then XLSP51 to XLSP100 in PCC group 2. Let these LSPs be consisting of 2 arrows. So then ER1 and ER2, let us configure them as IPv4 node ID. In that case, I may use the SID type as null. On the second ER also, let me configure it as SID type null and NAI type IP4 node ID. Now let's start the protocol. Okay, so all sessions have come up. Let's quickly go through the statistics that are available. So for PCE session per port and drill down statistics are available. PC sessions per port, we have sessions information, and then we have different types of messages, TXRX information, followed by PC initiate messages transmitted by the PCE, and then PC report message received, and if there are PC update and PC error messages transmitted or received, those statistics can also be populated over here. Similarly for PCC, similar stuff we have as statistics with different sessions up, total, not started, down, all those stuff, and then different messages, and the PC initiate RX and report message TX, all those informations are available under statistics. We can drill down by per session. So then since there are 10 PCC sessions, 10 rows will appear over here, and for each session we can have the corresponding statistics. Now let's check the PCC learned information. What LSPs that the PCC has learned. So the first 5 PCCs, the LSPs were having 3 arrows, and they were the type was MPLS level 20-bit. So you can see there are 10 LSPs over here, and each LSP consists of 3 arrows: 101, 201, 301. Now let's check the learn information of a PCC of the second PCC group and the PCE side. These will be having again 10 LSPs, but each LSP will be consisting of 2 arrows, and the SID type is IP4 node ID there, and node IDs are as configured on the PC side. And you can see that the source IP and destination IP was IPv6 address, and which were configured as this. Now let us check how can I update some LSPs on the fly. To do that on the PCC group, let us change some level values of the EROs that have been configured. Let's make it 1001. Change the level values of the first 2 EROs. And then apply. So this will result in PC update message transmission on the PCE side. If we see PC sessions per port, we'll be seeing that PC update messages have been transmitted. So PCC will be updating his LSPs. So let's see that corresponding LSPs, the level values should have got changed. Yeah, so we can see the first 2 level values we had changed from 101 to 1001 and 2001, and those have been reflected on the learn information on the PCC side. So now that's what the control part is. Now let's go to traffic and see how we can configure the traffic. So for traffic to configure, the PCC will be the source endpoint of any PCC traffic, and all these endpoints that are over here will be exposed as traffic source endpoint. Now one catch here is that in this expected initial LSP for traffic endpoint tab, these LSP names has to be similar to the symbolic path names of the LSPs that the PCE has installed on the PCCs. Unless these two matches, PCC will not be able to generate traffic, because once a PCC is asked to generate traffic over LSPs, it will check this symbolic path name with the symbolic path name in his learn information database. If the LSPs are if it finds that symbolic path name in his this particular symbolic path name in his learn info database, then only it will be able to fetch the corresponding label and send out the traffic. If this symbolic path name, expected symbolic path name configured here, doesn't match with the LSPs that has been installed by the PCE, then the traffic will not be able to get generated. Now go to traffic. Also there is a parameter, the maximum expected segment count. This denotes that PCC is expecting no LSPs from PCE will be consisting of more than 6 segments. So when the traffic when the PCC tries to generate traffic, it has to know till maximum what number of segments or SIDs or labels it will be doing the lookup for. Unless it knows, it is not possible for him to unless someone configures it, it's not possible for him to know till how many levels it will do the lookup. So if someone has configured by default it is 6, so PCC expects that no LSPs from the PCE will be having more than 6 EROs. If any LSP is having more than 6 EROs, then the corresponding traffic will not be generated. Let's add a traffic and expand the so this is the expected initial LSPs for traffic. This is the endpoint that will be used as source. So there are 100 and you can see the LSP names over here. And let us use the PCEP4 address as the destination over here. Normally this will be when ISIS is running with the PCC or PCE over here. ISIS route ranges will be the destination IP. But since over here I have only PCE, so I am using that as the destination. Let's track by MPLS flow descriptor and generate the traffic. So 100 packets should get generated. It has not got generated, so let's see what went wrong. So I had done this activation on the fly and then I did not apply, so that's why the traffic did not get generated. Let's see now. Okay, so since I had used IP4 node IDs, it is not able to find the IP4 node IDs as ISIS is not running, and that thereby it is giving an error that IGP needs to be running. So let me change the node. Let me change the ERO subtype to MPLS level, and then I will cover the node IP4 node ID case in a different topology. We can change this on the fly. Let's do the change. Let's check on the PCC side that the EROs should now be changed to MPLS level. Yeah. Now let's try to configure traffic. Okay, so now all the 100 packets have been generated. So first 50 will be having 3 levels, and the next 50 will be having 2 levels. Let's start the traffic. So you can see as we were used MPLS flow descriptor as tracking, so there will be 100 flows over here. So first 50 over here, and then the next page has the next 50. What we can do is we can use the current level, expose the current level to check the levels that has been used over here. That can be done by adding traffic options over here. Just quickly regenerate it and send the traffic, apply and traffic. Okay, now we can see the outer and inner the current level. So for first 50 endpoints, there will be having 3 levels, and then for the next 50 endpoints, the last 50 flows should have 2 levels, since the last 50 LSPs were consisting of 2 EROs. So this is how traffic gets generated with when the ERO sub SID type is MPLS level. Next, I will just quickly show a topology where the traffic will be generated using IP4 node address. Let me quickly load a configuration. Let me quickly explain the topology. So I have PC configured over here. I have a emulated PC channel group, and I have one simulated PC channel group. So this emulated PC channel, this session is with the emulated PCC over here. This PCC is again having a chain of 9 simulated PCCs, and this simulated PCC group is having sessions with these 9 simulated PCCs. Also, there is this ISIS configured over both these stacks, both the side PCE and PCC. These nodes are getting advertised by ISIS SR, and the ISIS SR on the PCC side will have the levels for the IP addresses advertised by this side of the ISIS, the PC side of the ISIS. Let's see that what IP addresses has been configured over here, for which the PCC ISIS will have the levels. So on our simulated bridge, I have segment routing enabled, which node prefix this, and there are some IP4 node routes as well. On the emulated PCC channel side, the EROs that have been configured is having IP4 node ID has those 5.11 and 5.12 and 5.4567 and 910, all these addresses. These are actually the addresses that are getting advertised by ISIS SR. Now let's first start the topology. First of all, we'll check after the ISIS session comes up, we'll see that the ISIS running in the PCC side should have learned the SIDs or labels corresponding to the IP addresses on the PCE side. Let's do a fetch learn info on the ISIS side on PCC, and yeah, so we have learned these 5.1.1 prefixes with levels 26,001, 2, 3 and so on. Now we have also seen that these 5.11 addresses are actually used as IP4 node ID in the LSPs that the PCC has learned. So you can see that the PCC has learned the LSPs which EROs are IP4 node IDs of 5.1.1.2, 3 and so on. Now when we generate the traffic, this is the traffic that is already configured, which has endpoint as the emulated PC as the endpoint, and it has a source endpoint, and the destination endpoint is some ISIS routes. That goes to flow tracking and track by flow descriptor, and then generate the traffic. Now what happens is now PCC sees that the EROs are of the type IP4 node, so it doesn't have any direct label, so it goes to ISIS and segment routing, ISIS segment routing, and fetches the corresponding labels for those IP4 node IDs, and these are the labels that it has fetched from the ISIS-SR database running on the PCC side. Now let's start the traffic and we'll be able to see those levels. So you can see there are 10 LSPs, and these are the labels that were used. 3 arrows were there for each LSPs. There are 10 LSPs because on the expected LSP side the configuration was 10 LSPs. Yeah, so expected initial LSP for traffic was 10, so there were only 10 LSPs over which the traffic got generated. So this is how the PCC and PCEs are configured, and along with traffics with different types of SID type and NAI type. We support EROs, ERO sub-objects type as MPLS level 20-bit, MPLS level 32-bit, or NAI type as IP4 node ID or IPv6 node IDs. Other type of other type of NAIs or SID or SID type as SID segment index is not supported. So this is how is the configuration of PCC and PCE's sample configuration done over back-to-back ports. So that's the end of the demo. Thank you for your time.